Good afternoon, everyone. My report is about the groundwater. So, groundwater is considered a very important natural source in arid, semi-arid, and dry regions. This may be the only source of water supply. So, even in humid areas, groundwater is considered a better resource for many economic and hygienic reasons. So, some of the reasons are groundwater is free from pollution and the groundwater storage is free from atomic attacks. It can be developed at a small capital cost and least possible time and intensive irrigation. It can be practiced with double and triple cropping including commercial crops. And it can be used for supplemental irrigation during periods of deficient water supply. So, where does groundwater stored? Groundwater stored in a aquifer. So, aquifer is a body of porous rock or sediment saturated with groundwater. So, groundwater enters an aquifer as precipitation seeps through the soil. It can move through the aquifer and resurface through springs and wells. So, formations that serve as a good aquifer are gravel, sand, alluvium, lake sediment and glacial deposit, limestone with cavities formed by the action of acid water, granites, marble, and heavily shattered quartzites. Characteristic of a aquifer. Number 1 is the porosity. The number and size of pore spaces, fractured, joined, in bedrock provides storage for groundwater. We can solve the porosity by adding the specific yield and the specific retention. So, specific yield is defined as the ratio of the volume of the water that saturated rock or soil will yield by gravity to the total volume of the rock or soil. The specific retention is the percentage volume of water which will not drain by gravity. So remember, the formula for solving the porosity is adding the specific yield plus specific retention. Second characteristic of aquifers is the permeability. The connectedness of pore spaces, fractured joints in bedrocks provide transmittal for groundwater. So the different types of geological formation of groundwater. First is the aquiclude, a geologic formation that can absorb water but cannot transmit significant amounts. Examples of these are clays and shales. Second is the aquifod, a geologic formation with no interconnected pores and hence can neither absorb nor transmit water. Examples are basalts and granites. Third, the aquitard, a geologic formation of rather impervious nature which transmit water at a slow rate compared to an aquifer. Examples are clay lenses interbedded with sand. So remember, the aquiclude can absorb water but cannot transmit. The aquifod interconnected pores, it cannot absorb nor cannot transmit water. The aquitard can absorb but at a slow rate compared to an aquifer. Confined in unconfined aquifer. So, what is unconfined aquifer? So, unconfined aquifer are those into which water seeps from the ground surface directly above the aquifer. An unconfined aquifer has little to no overlying sedimentary layers. There is no confining layer of the clay or other impermeable sedimentary layer. This aquifer under water table condition and well drilled into this aquifer is called a water table well. So, a water table well is on the upper level of an underground surface in which the soil or rocks are permanently saturated with water. It is also affected by withdrawing excessive amount of water from wells. So next is the confined aquifer. An aquifer below the land surface that is saturated with water. Confined aquifers are usually sandwiched between two permeable layers. The confining layers provide pressure on the aquifer, allowing the groundwater to rise to the surface under its own energy. No pumping required. Artesian well is a well from which water flows under natural pressure without pumping. So, we can see on the slide what is the artesian well. So remember, artesian well is a well that flows under natural pressure without pumping. So if the piezometric surface is above the ground level at the location of the well is called flowing artesian well. Since the water flows out of the wells like spring, and if the piezometric surface is below the ground level at the well location, the well is called the non-flowing artesian well. Remember, the flowing artesian well is piezometric surface is above the ground level, and non-flowing artesian well if the piezometric surface is below the ground level. Flowing artesian well, piezometric surface above the ground level. Non-flowing artesian well, piezometric surface below the ground level. A perch water table is a water is standing above an unsaturated zone. So the storage coefficient of the aquifer. Storage coefficient is the volume of water given out by a unit prism of aquifer when the piezometric surface or the water table drops by unit of depth. We can solve the storage coefficient of the aquifer using the formula shown on the slide. The specific yield and the storage coefficient values have to be determined for the aquifer in order to make estimate of the change in the groundwater storage due to fluctuation in the GWT or piezometric surface from the relation. So, first we are going to know the value of the specific yield and storage coefficient to know the change in the groundwater storage by using the formula shown on the slide. We have a example. Number 1. In a certain alluvial basin of 100 km squared, 90 mm cube of groundwater was pumped in a year, and the groundwater table dropped by about 5 meters during the year. Assuming no replenishment, estimate the specific yield of the aquifer. If the specific retention is 12%, what is the porosity of the soil? Before we can solve the porosity of the soil, we need to get the value of the specific yield by using the formula of the change in groundwater storage. So change in groundwater storage is equal to involved area of aquifer times change in groundwater storage times specific yield. So change in groundwater storage is 90 times 10 power of 6 is equals to 100 times 10 power of 6 times 5. So SY, or the specific yield, is equals to 0.18. So the formula for the porosity of the soil is adding the specific yield and the specific retention. So we now know the value of the specific yield, which is 0.18. So we are going to add the specific retention, which is 12% or 0.12. So adding the two value, it is equals to 0.3 or 30%. So we know this porosity of the soil. Number 2. An artesian aquifer, 30-meter thick, has a porosity of 25%. In bulk modulus of compression, 2,000 grams by centimeter squared. Estimate the storage coefficient of the aquifer. What fraction of this is attributable to the expansibility of water? Bulk modulus of elasticity of water. So we are going to solve this using the storage coefficient formula. So storage coefficient is equals to specific weight of water times porosity, thickness of the confined aquifer, times 1 over bulk modulus of elasticity of water plus 1 over modulus of compressibility or the elasticity of the soil grains of the aquifer. Substitute the value for the formula. So 1,000 times 0.25 times 30 times 1 over 2.14 times 10 power of 8 plus 1 over 0.25 times 2 times 10 power of 7. It is equals to 1.54 times 10 power of negative 3. So the storage coefficient due to expansibility of water as a percentage of storage coefficient above. So the answer is 2.28%. That's the end of my report. Thank you.